portion of the class. And about probably 75% of the class revolves around the unit circle. Okay, so the unit circle is just a circle centered at 0, 0 with a radius of 1. With a radius of 1 on the xy plane. Okay. So if you remember the formula for a circle, x minus h squared plus y minus k squared equals your radius squared. Okay. So if your center is 0, 0, which is your h and your k, and your radius is equal to 1, then that just gives us x squared plus y squared equals 1 as your unit circle. Okay, so we're going to look at the 4 quadrants on an xy plane. So we have just our regular xy plane, our x-axis and our y-axis. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Or in most cases, I just write it as Q1, Q2, Q3, and Q4. All right, any questions so far? All right, I'll leave that up there for a few seconds. Actually, let me draw a quick, I guess you could say, sketch of a unit circle. Well, that should be a circle, but okay, so here you just have a radius equal to 1. So this is just your unit circle. And really, that radius is the same everywhere. All right. Okay, so let's say, for example, we wanted to show that negative 5 over 13 And 12 over 13 is on the unit circle. Okay, so we know that x squared plus y squared equals 1. That's our unit circle. And we know if we have the point, negative 5 over 13, and 12 over 13, that this is our x, and this is our y. This is our regular x comma y. So if we plug those in, you have x squared, so negative 5 over 13 squared, plus y squared, plus 12 over 13 squared, is equal to 1. Okay. So if we simplify this, negative 5 over 13 squared, negative times negative is positive, so that just becomes 25 over 13 squared, which is 169, plus 12 squared is 144, over 169 is equal to 1. And 25 plus 144 is 169, so you end up with 169 over 169 equals 1, which is true. Okay. So you know this particular point is somewhere on the unit circle. All right, so let's say if they just gave us one of the points. So they gave us just the x or just the y, and we had to solve for the other. Okay, so let's say, for example, if you want to find the y coordinate, of, let's say, square root of 3 over 2 and some unknown y in the unit circle in quadrant 4. Okay. Now, when they tell you exactly which quadrant, they do that for a reason. Because you want to notice that for your x and your y, in quadrant 1, x and y's are both positive. So x is positive and y is positive. In quadrant 2, remember, x is negative, but y's are positive. Now in quadrant 3, all your x values are negative and your y values are negative. And in quadrant 4, all your x's are positive and your y's are negative. Okay, so when they tell you the quadrant, that's the reason why. Because they know that in the case that if you happen to get a positive and negative answer, since you're solving for y, you know your y is going to be negative. Now, they told you if it was in quadrant 2, then your y would have been positive. Okay, so we know already what our x is. So we know our x squared plus y squared is equal to 1. And since we have our square root of 3 over 2y, you know x is equal to square root of 3 over 2. So we just plug that in and we solve for our y. Okay, so that's square root of 3 over 2 squared plus y squared equals 1. So if we just subtract square root of 3 over 2 squared, so y squared equals 1 minus square root of 3 over 2 squared. Okay, so if we go ahead and simplify that, and I'll bring that up here, give us a little bit of room, y squared equals 1 minus square root of 3 squared is just 3. 2 squared is 4. So if we make that 1 4 over 4, y squared equals 4 over 4 minus 3 over 4, which means that y squared is equal to 1/4. But if we square root both sides, the square root of y squared is just y. Square root of 1 over 4, go ahead and do that now. You have the square root of 1 over the square root of 4, which is positive or negative 1/2. And this is where the quadrant comes in. Because they told us it's in quadrant 4, we know we're going to pick the negative 1/2. Since are in quadrant 4, y equals negative 1/2. All right. Any questions on that one? All right. Ooh, anyone's still writing? Still leave it up for a few seconds. All right. Okay, so let's say we look at our unit circle points. And hopefully I can draw a decent looking unit circle. Okay, so that's your x, and that's your y. So let's say if we make, for our x squared plus y squared equals 1, if we make x equals 0. Okay, so if x is equal to 0, then y can equal positive or negative 1. So if x is equal to 0, y can equal 1 or negative 1. If we make y equals 0, which would be at these 2 points here. So if y is equal to 0, then x can equal 1, or x can equal negative 1. Okay. So those are 4, I guess you can call them axis points on a unit circle. Okay. So what we're going to do is we're going to now look at all those points, well not all, but a key couple of points in between there. Okay. And we're going to do that by using the degrees. Okay, so let's say if you have, here we'll call that our initial axis. Bless you. Bless you. Okay. And let's say, just keeping our radius at 1, we decide to swing it up to a certain point. Okay, so let's say we swing it up that way to where now we started here, but now we're here. Okay. Now the amount of room that we actually did swing it up, we're going to call that theta. Okay. So the Greek letter theta, we use that to count the number of degrees that it actually did swing up. So the degrees that in this case, it would be the terminal axis, or terminal point here. Which is basically where the swinging stops. Measure the degrees between the initial and terminal points. Okay, so we know that if this theta is going counterclockwise, then we know it's going to be positive. Oh, let's say theta is going counterclockwise. Yeah, I could have left if in there. So theta counterclockwise. Then we know that it's positive. Okay. Now if it's going clockwise, the other way around, so let me draw a quick little comparison there. So if it's going that way, move that down. There we go. It's going clockwise. Then we know it's negative. Okay, so if we have that same graph, and instead of going this way, we're not going the other way. So now we're going to give some kind of starting values to let us know just how many degrees we're going. All right, so if we have that unit circle, okay, so we know that this is 1, 0, and this is negative 1, 0. And this is our 0, negative 1, and 0, 1. Okay, so if we start it right here at our initial point, if we swing all the way up here, we know that a right angle will give us 90 degrees. So this is 90 degrees, which is also pi over 2 radians. So if we swung up to this y-axis, that's what our degrees would equal. So that's Those would be our theta. Okay. Now, if we kept on going and we swung all the way here, we just basically made a straight line. So when you have a straight line, your theta is equal to pi, or 180 degrees. Okay. So if we kept going a little bit more, let's say we started here and we swung all the way down to this line. So if we swung all the way down to here, our theta would equal 270 degrees, or 3 pi over 2 radians. Okay, so if we kept swinging just a little bit more and made a complete circle, ended up right back to the same spot, then our theta would equal 360 degrees, or 2 pi radians. Oh, sorry about that. Okay, so with this, and actually I think I'll draw, and I don't like drawing too much on one unit circle, it looks kind of jumbled. So I'll draw a second unit circle. Okay, so right now we're just going to focus on quadrant 1. Okay, so just quadrant 1 here. So let's say we pick some point in quadrant 1. Doesn't matter how high or low it is. We're just going to pick a point. Okay, so we know if we pick that point, then that means our theta swung up so many degrees. Okay, we don't know how many degrees. We just know it swung up a certain number of degrees. So now what we're going to do is we're going to figure out, okay, how do we, find out what that point is using that theta. Okay, so we know here, this is our x and this is our y. So we go x to the left, x to the right. So we know at some point x comma y. But if we're going to use that x comma y point, but somehow using that theta to find it, then we have to say, okay, well, we know our x, we know our y. Here, we know our radius is equal to 1, so our hypotenuse is 1. But in order to use those thetas, we have to kind of define it differently. So here you have the ratio of the opposite and adjacent. I guess you can say the radius. Opposite over hypotenuse, rather. So since our hypotenuse is 1, we're going to call our x cosine of theta. So cosine theta is just cosine of theta. And we're going to call our y our sine of theta. And really all it does is just compare the ratio of sides, and the names really don't mean much, just the names they were given probably a couple thousand years ago. Okay, so that means your x and your y can now be called your cosine theta, sine theta. Okay, so put that down here. So your x, y in terms of theta cosine theta, sine theta. Any questions so far? All right, I'm still writing. All right, so let's say for example, let's say if the terminal side of the angle goes through, let's say the point 2 square root of 5, clean that up a little, over 5, comma, negative square root of 5 over 5 on the unit circle. Then what is sine theta? Okay, so we know that your 2 square root of 5 over 5, comma, negative square root of 5 over 5, we know that's your x, and that's your y. But we also know that x is equal to cosine theta, and y is equal to sine theta. Okay, so that means your sine theta is just negative square root of 5 over 5. Right. Any questions on that one? All right, so let's say if we have one. Okay, so the terminal side, let's say the angle theta, intersects the unit circle in the first quadrant. At x equals 3 over 8. Okay. So what are the values of sine and cosine? Sine of theta and cosine of theta. And that'll be cutting off in about a minute, so I might as well